In this video, we're going to take a peek at the questions on the review packet from numbers 11 through 24. If you look at your review packet, the questions 11, 12, 13, and 14 deal a little bit more with our triangle sum theorem, which says, like we said in the last video, that the sum of the angles in a triangle add up to 180 degrees. Number 17 through 20 deal with finding x in the exterior angle theorem, and number 21 through 24 deal with exterior angle theorem as well, but we're going to plug numbers back in to solve for angles. So let's go ahead and get started here, looking at 11, and let's do 11 and 13 here. So if I'm looking at 11, I know that in the bottom triangle I have angles of 45 degrees and 70 degrees. In the top triangle I have an 84 degree angle, but I'm looking for the very top angle. This is our ultimate goal right here. What I usually tell people to do is start with a triangle where you know two bits of information. Because if I know that I have 45 degrees and 70 degrees in one triangle, I can figure out that third angle. What I do is I add them together to get 115. Then I take 180, take away 115. That's going to be 65. If I know this angle right here is 65, by vertical angle, we know that this angle above it is 65 degrees. And again, I have another triangle sum problem here. I'm going to add 65 plus 84. It's going to get me 149. I'm going to take 180, take away 149. That's going to get me 31 degrees. This angle right here is 31 degrees. In question number 13, I have this triangle on the left where I know two angles. I know this 82 degrees in the middle here. I know 70 degrees, in the right triangle, and we're looking ultimately for this bottom right angle of the right hand side triangle there. So let's start with what we know. We know 80 degrees and 57 degrees in this triangle. Let's add those together. 137 degrees. The way I get this angle down here is I do 180, take away 137. 43 degrees here. This one's a little bit trickier to see. If you notice, these three angles together right here make a straight line, which is 180 degrees. So if I take 43 plus 82, that gets me 125. And I get this angle right here by taking 180 minus 125. That's going to get me 55 degrees. Again, I'm working with triangle sum theorem here. 55 plus 70, it's 125. And I take 180 minus 125, and I get 55 degrees. That is this angle right here. In the next set of problems here, we're dealing with the exterior angle theorem. The exterior angle theorem says that if you have an exterior angle right here, you find this angle by adding the two remote interior angles, or the two non-adjacent interior angles. So this one's really quick. You add 68 and 78. You get 146. That one's pretty basic. Let's take a peek at one that's a little bit harder. This angle right here, our exterior angle, equals the sum of these two guys. So you can put a plus sign between it if you'd like. 26 plus 6x minus 6. I'm going to combine like terms on the right hand side. Nothing combines on the left. From this point you have four choices on how to begin this problem. I'm going to subtract 6x from both sides to get my variables on the left. 9x take away 6x is 3x, plus 7 equals 20. From this point I take away 7. And I divide by 3. My answer is x equals 13 over 3. I feel like I did something wrong here because we got a fraction. Oh, I see what we did wrong here. This is supposed to be a minus 7. Which means we're actually going to add 7 here. It's going to be 3x equals 27. When we do 27 divided by 3, my answer is actually 9 now. The error I made was when I transferred my minus 7, I put a plus 7 here instead of a minus 7. Again, that changes it, because to undo a negative minus, you subtract, or you add. That's where I went wrong. Alright, number 19. I know that this is my exterior angle, 114 degrees. That's going to equal the sum of my two interiors. So I'm going to add 5x plus 3 plus 6x minus 10. Can I combine my like terms on the right side? There's nothing to combine over here, it's just 114. Let's take a peek. I can combine those and those. 5x plus 6x is 11x. 3 minus 10 is negative 7. I'm not going to make this mistake again. Add 7 to both sides. 121 equals 11x. Divide by 11. X equals 11. And again, we've solved in both of these because we're looking for x in our directions. Now, if you look at numbers 21 and 23 here, notice they're actually asking us to solve for an angle instead of just solving for a variable. So let's go ahead and set this up again. We know the exterior angle, which is 10 plus 10x, equals the sum, we're going to add, of our two non-adjacent interiors, 44 plus 6x plus 14. Nothing to combine on the left side. On the right side I combine 44 plus 14. That gives us 58 plus 6x. I'm going to minus 6x from both sides. I have 10 minus 4x, or plus 4x, equals 58. Next step would be to divide, or minus 10 from both sides. 4x equals 48. To get x alone, I divide by 4. And x equals 12. Keep in mind that I'm not done here. I'm looking for angle HRS. If I trace from H to R to S, that's this angle right in here. That's my exterior angle. I'm going to plug my x back in here. So I'm going to say 10 plus 10x. And now I need to plug my 12 in. 10 plus 10 times 12, well, that's 10 plus 120, which gives me 130 degrees. Here I'm looking for angle F. Again, I'm not looking for x, I'm looking for an actual angle measurement. So the way I set this up is my exterior angle, 8x plus 12, equals the sum of my two non-adjacent interior, 60 plus 7 plus 3x. Nothing to combine on the left side. On the right side, I combine 60 plus 7 to give me 67 plus 3x. 8x plus 12 stays on the left. I'm going to subtract 3x to combine my x's on the left-hand side. 8x minus 3x is 5x plus 12 still, equals 67. I'm going to minus 12 from both sides. Now I have 5x equals 55. I divide by 5. My x equals 11. Again, that's not my final answer because I'm looking for f, not x. So angle F equals this angle right here, 7 plus 3x. So angle F equals 7 plus 3x, which equals 7 plus 3, and I substitute my 11 in, which equals 7 plus 33. 3 times 11 is 33. 7 plus 33 is 40 degrees.